Okay, I'm here to record some selected answers to homework problems. The first thing I'm just going to focus in on is just remember the power rule for taking integrals. That's where the integral, that's the worst integral sign ever, sorry Quinn. For taking the integral of x to the n dx, that is equal to 1 over n plus 1 x to the n plus 1. The key point is raising the exponent first. If you have a standard function with no composed functions, you're good to go. So for number 1, the integral of x to the 10th dx equal, what's that? You said I forgot something? I see it now, Quinn. You're right. I forgot a plus c on there. So x to the 10th, the integral is x to the 11th, with a 1 over 11 on the outside, plus c. 3, we're doing the integral of 4x to the negative 6th dx. That's going to be x. We're going to go up 1 to the negative 5th. The 4 stays on top of the fraction. Negative 5 goes under, plus c. You can write the 4 out front. You can write the negative sign out front. Either way, it's just fine. For number 7, I've got the integral of 4 cosine 7x dx. So there are two pieces here I'm focusing in on. Any constants that I might have. I can take that and put that outside till later to use.
This one doesn't have.
So I've moved the 4 out in front, because it's not going to come in handy to me, so I'm taking the integral. Here's our 4 of cosine 7x dx. And what I have to remember is I need to get the derivative of the inside and the dx out over here. In order to do so, I've got to look at the function, cosine of 7x, where 7x is the inside, and the derivative of 7x equals 7. So I know in that set of parentheses I need to have a 7. But I can't just put a number in there. I can't change the function. So I really want to counteract that 7 by putting a 1/7 out in front, because then my function doesn't change, because 7 times 1/7 equals 1. So now I look at this function, and I notice that the derivative of the inside is in the parentheses, and the letter dx is in parentheses. So now I can integrate it, and I just have to remember that that set of parentheses disappears. So I'm going to multiply the 1/7 and the 4 together. So I got 4 over 7. The integral of cosine is sine of 7x plus c. So this is the integral of that function, and for this one I'm just going to test it by taking the derivative and seeing if I get back what I started out with. So the derivative of 4/7 sine of 7x, the derivative is going to be 4 over 7 times sine, who wrote sine? Silly person. The derivative of sine is cosine 7x times the derivative of the inside, which is 7. And the derivative of a constant is 0, so it goes away. This 7 cancels with that, and I'm left with 4 cosine 7x. And as you can see, that one worked. So let's try a couple more while we're working here. Let's take a look at number 9. It's the integral of 5e to the point 3x dx. So I'm going to write the 5 out in front. Integral of e to the point 3x dx. My composite function is e. The derivative of the inside, which is 0.3 to the x, the derivative of that is 0.3. So I know right here I have to have a 0.3. And out front, I'll put a 1 over 0.3. I know it's not good form right now, but I'll fix all that in a little bit. So now I have the derivative of the inside function is here. I'm just going to cover that up. And when I take the integral, the derivative of e to the something is e to the something times the pieces I had left, 5 and 1 over 0.3. And I can simplify that. I usually do this quick in my head. 0.3 is 1 over 3/10, so it's equal to 10 over 3. So the correct answer is going to be 50 over 3 e to the point 3x. 11. No one likes this one. 4 to the m dm. I have no inside function, so I'm just dealing with the 4 to the m, and the integral of n to the x is n to the, oh, who wrote that? Hey, did I put a plus c on there? Oh, Quinn, that's prima dollar, you're right. Plus c. The integral of 4 to the m is 1 over ln of 4, 4 to the m plus c. 13, integral 4v plus 9 squared dv. Okay, I see my inside function. The derivative of the inside function is 4, so I need there to be a 4 here, because that's what goes with it. I counteract that with a 1/4 outside. So now the integral of something squared is going to be something cubed to the 1/3 power times my 1/4. So it's 1/12 4v plus 9 to the 3rd plus c. Next is 15, integral 8 minus 5x. Oh, let's clean that up. Sorry, Quinn. 5x to the 3rd dx. Going to go through this 8 minus. That's a minus sign. Going to go through the same process. Going to write it down. The 3rd dx. The derivative of the inside function would be -5, so I need a -5 here. Counteract that with a -1/5 out front. And the integral of something to the 3rd is something to the 4th with a 1/4 out front. And I'm going to keep the original -1/5. I get -1 over 20, parentheses, 8 minus 5x to the 4th. 17 is the integral sine x to the 6th times cosine dx. So before cosine x dx. So before I start moving anything, I'm going to look at the inside function. The inside function is sine of x. The derivative of sine of x is cosine of x. So I already have it there. So I'm going to make a set of parentheses here. Those two derivatives, derivative of the inside and the letters dx, disappear. So I'm taking the integral of something to the 6th, which is going to be that something, to the 7th, with a 1/7 out front, plus c. Okay, 19 is cosine to the 4th theta times sine of theta dx. So just got to be careful about how I work here. The inside function is cosine of theta, and the derivative of cosine equals negative sine. Now, if I look what I have, I see the sign, but I don't have a negative sign on there. So I can put one negative sign and two negative signs, and it keeps the problem the same, but allows me to have the derivative inside the parentheses. So I'm now done with this section. When we integrate, it's going to go away. And the derivative of something to the 4th is something to the 5th with a 1/5 out front, not forgetting the minus sign, plus c. On to 21. 21 says the integral of x squared plus 3x minus 5 dx. I can just think of each part separately. The answer to that is x to the 3rd with a 1/3 out front, plus x squared with a 3 over 2, minus 5x plus c. 23 is a little tricky. 23 says the integral from x squared, of x squared plus 5 to the 3rd dx. So I'm going to take a look at it. What's the derivative of x squared? Well, the derivative of x squared is 2x. I can counteract the 2 that's involved, but I can't do anything about this x, because if I put an x on this side, I got to put a 1 over x there, and it changes the whole problem. So by trying to do this reverse chain rule, I can't solve this problem out. But it can actually be done, because I could do the math beforehand. I can do this to the 3rd power, which would be the following. So I did Pythagorean. Let's go the Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. It's equal to the integral of x squared to the third plus 3x squared to the second times 5 to the first plus 3 times x squared to the first, 5 to the second, plus 5 to the third, which is equivalent to this when expanded out, which when you solve it out will be 1/7 x to the 7th. It's 15 over 5x to the 5th, plus 75 over 3x, plus 125x, plus c. It's a long problem, I know. Okay, the integral of e to the secant x times secant x tangent x. A lot of stuff going on here. Don't be fooled by all the extra stuff. Look where there's a composite function, a function inside of another. That's this one right here. The inside function is secant x. What is the derivative of secant x? Well, it's secant tangent. Hey, we already have it there. Parentheses around this. When we integrate, this is going to go. And the integral of e to the something is e to the something plus c. Next we have the integral of secant squared x. And this one is a special situation, and it's just this one to think about. What will give us I couldn't do this with any of the composed rules. What has a derivative that is secant squared? TSS, yes, a special one, the integral. This one is tangent x plus c. And now we're going to look at 29, which is the integral of tangent 7x times secant squared x dx. I know I got two composed functions here. Let's deal with the tangent. What is the derivative of tangent? It's secant squared. It's already sitting there. So I'm just going to put my parentheses on that. And the integral of something to the 7th is going to be that something to the 8th times 1/8 plus c. And then my last problem, which I need some more room to work on, let's find a spot, we'll go right here, is the integral of cosecant to the 9th x times cotangent x dx. And this is one of the trickier ones they can give you. And I can see here's my composed function, cosecant to the 9th x. The derivative of cosecant equals negative cosecant x cotangent x. So if I look at this equation, I already have the cotangent x, but I don't have a cosecant x. Well, it only happens this way with cosecant and secant. I can borrow one. I can rewrite this equation as cosecant 8th x times cosecant x cotangent x. It won't be any other function but this where you can borrow those from. And now, is the derivative of cosecant cotangent? Almost. It's a negative. I need a negative here. So I need a negative there. Now I'm forgetting about this whole piece. And something to the 8th is cosecant 9th x. It's the negative 1/9th plus c. There's my c. And that is, of course, the trickiest one they can give you.